So the next system that will be discussed is the parasympathetic nervous system. This is your rest and digest. It's a calming, conserving energy system. It starts in the brainstem and your sacral. Sorry, I need to charge my laptop. That's my notes. Um, the brainstem and the sacral parts, S2 to S4 to be exact. And some of the major cranial nerves involved are going to be your cranial nerve 3, your oculomotor, your cranial nerve 5, which is your facial, your like it has a bunch of face muscle, salivary, and your tear glands. Um, just think of like facial secretions. It's kind of controlled by that. The glossopharyngeal, the vagus. It's mostly the parasympathetic is mostly controlled by the vagus nerve, which controls a lot of your abdomen, your that just the abdominal region, and then your it has sacral fibers. The sacral fibers go to your pelvic organs, your bladder, reproductive organs. And so parasympathetic ganglia has quite a few different ganglia that it uses. So actually it has only 2. So we have a terminal ganglia, which is near the target organ. These ganglion are short. So that's worth saying that the parasympathetic you have short ganglia, like your preganglionic are long, but your postganglionic are short. And those postganglionic tend to be terminal or intramural ganglion. Terminal meaning, again, like I said, they're in your target organ. Intramural meaning they're inside the organ. And the postganglionic are short because they don't really have to travel much. They're already synapses close to the organ that they're intended to. So they tend to be small. But the parasympathetic, so it has a preganglionic to ganglion. And just similar to the sympathetic system, it releases acetylcholine. The receptors used are going to be nicotinic receptors, and they tend to be excitatory. So like nicotinic receptors, if you think about it, nicotine is kind of, to me, what I have learned is nicotine, it kind of releases dopamine, and dopamine is excitable. So that's a good way to think about it. Nicotinic receptors are excitable. And then you have your postganglionic to target organs. They release also acetylcholine, but these are muscarinic receptors. And they can be a little bit of both, excited or inhibitory. A good way to think about this, I know I'm probably butchering how you pronounce it. Music can be excited or inhibitory. Muscarinic, muscarinic. It reminds me of music, just how you say it. It's a good way to remember it, for me at least. So nicotinic receptors are found on all autonomic ganglia. So they exist in both the sympathetic and the parasympathetic system. They are also found in neuromuscular junctions. So neurons that have to do with the muscular system and the skeletal system. So what happens here, acetylcholine binds, sodium channels open, depolarization, and as depolarizes, it's always excitable, always keeps going. And then for the muscarinic receptors, they're only found in parasympathetic, not in sympathetic, because they can be inhibitory. And or they can cause like inhibition and excitatory, like they're both. So for instance, it can be excitable for your stomach and digestive system moving forward, but it inhibits your heart rate. It slows down, like when we're resting, heart rate is slow. So here what happens, your acetylcholine binds and it activates a G protein pathway. And both, so these systems rely on dual innervation. Dual innervation is when organs are both receiving sympathetic and parasympathetic input. For instance, the heart. During the sympathetic division, your heart increases in heart rate, but the parasympathetic, it slows down. So there is influence. It is influenced by both systems. So that is the idea of dual innervation. Except blood vessels. Blood vessels are only controlled by sympathetic fibers. That is because norepinephrine, which is only released in sympathetic postganglionic neurons, dictate the tone and the width of blood vessels. So, for instance, you have more norepinephrine, your blood vessels are going to be tighter. Less, your blood vessels dilate. But so they're always a little bit contracted. And so this is called sympathetic tone. Kind of your body is always in position to be in a full sympathetic or a full parasympathetic state. Kind of a little bit there, a little bit just ready. And so there are autonomic plexuses. These are interconnected networks of sympathetic and parasympathetic fibers and nerves surrounding major organs. For instance, my heart, it has nerves, it has fibers that are innervated by the sympathetic and parasympathetic postganglionic neuron. And kind of, so this kind of helps just the heart be ready, I guess. And so you have the cardiac plexus, the pulmonary plexus, you have a celiac, which is your stomach, a hypogastric lower stomach, esophageal, the mesenteric plexus, which is like the upper large intestine. Just it ensures like the organs receive basically a balanced autonomic control, right? And so then you also have visceral reflexes. So visceral reflexes, visceral meaning internal organs, reflex, just an automatic response. These are controls of automatic responses of internal organs. So you have your receptor, your sensory neuron, the processing center, which is typically interneurons, ganglion, I guess. Preganglionic neurons, postganglionic, and target organ. So that's kind of the pathway they go. Receptor, sensory neuron, processing center, preganglionic, postganglionic to target organ. And then on the other hand, you have short reflexes. These reflexes, forget about it. They know nothing about the central nervous system, nothing. But they bypass the CNS entirely. It is controlled in ganglia of the enteric nervous system. We haven't mentioned that, but the enteric nervous system is kind of like a third nervous system. And it exists in the digestion. It bypasses because this system needs quick responses. You don't have time to go to the central nervous system when you're dealing with like all these food acids that are detrimental to the body. And so they just stay local. They are fast. They just do regulation. So long reflexes, they go to the central nervous system, and they are kind of like head honchos. They create a bigger, larger picture and an organ level response. So it could be like it's a greater response. Short reflexes don't care about the CNS. They just stay here and just kind of operate quickly. And then the highest level of control, so kind of the big honcho, the big jefe, the big whatever you want to call it, is the hypothalamus. It controls, really, it's kind of taking the backseat, controlling a lot of this autonomic nervous system. So it determines when the sympathetic or the parasympathetic activates. It monitors emotion, temperature, metabolism, stress, maintains homeostasis. But yeah, so I would say some of the most important things to know for this chapter, for this idea of what the autonomic nervous system is that parasympathetic, in terms of parasympathetic is made of cranial nerve 3, the ocular motor, cranial nerve 7, the facial, cranial nerve, the glossopharyngeal, the vagus nerve, which controls a large extent of it, and then the sacral nerves 2 to 4. Acetylcholine is a nicotinic ganglia is always excitable. And acetylcholine in muscarinic is in organs, and it can excite or inhibit, and this is postganglion. Remember, muscarinic and organs, muscarinic receptors are closer to organs because most postganglionic neurons in the parasympathetic are intramural or terminal ganglia. So remember that parasympathetic is muscarinic. Blood vessels are only sympathetic controlled, by norepinephrine. And so your short reflexes kind of deal with the digestive, the long reflexes deal with CNS processing, and the hypothalamus is the master controller. But yeah, that's basically it. It's kind of a unique, intense system that just has a lot of levels to it. I mean, I'm trying to look over my notes if I've missed anything, but I think that kind of captures most of it. Yeah. Nicotinic and muscarinic are cholinergic receptors. Yeah. Well, thank you.